Okay, YouTube, I got the jumper cable for the iCharger set up. So I showed you the banana jacks. I added on to the alligator clips here, and then I came down here and stuck on a mating XT60 connector, and then I can plug that in here, and I can either plug it in to be the charger output lead, or I can also plug these into the battery clamps and have that as a power input. So first thing I want to do, I've just charged this battery. I had it on the shed solar panels for a couple of days, and then I put it on my iMax B6 just to check, and it went through its tapered off charge cycle and said it was full. So what I want to do here is measure the internal resistance. So to do that, you click through until you get to special modes, hit that button, and then you go through a couple of clicks, measure internal resistance. You hold that down, and there we go, 92 milliohms. Let me go record that, and then we'll come back and I'll start a discharge test here. Okay, I got that data recorded here. Let's go over and lithium, nickel metal hydride, NiCad, then you go to lead. Okay, charge. I want to do a discharge, and this is a 26 amp hour battery, so I want to do a 20-hour rate, which is 26 divided by 20, or 1.3 amps. So let's go up there. So that's a 1.3 amp discharge, and we'll do that. And I'll do regenerative, so I'm going to pump the 26 amp hours back into the 4S pack, and we'll see how that goes. We're dropping down. So I will come back in the morning and we can check out the results. Okay, YouTube, we finished the discharge test, and like I showed you before, I clipped the charger leads onto the jump start clamps on the jump start pack, and I'll mention a little bit about that later. And just to show you here the final number, so we finished in 19 hours 37 minutes, so pretty close to the 20-hour discharge rate. I did the 1.3 amps, and we came out 25,750 roughly. Let's go take a look at log view and see what the data looks like. Okay, here we are in log view, and I left the PC running overnight again to capture the data from the iCharger battery charger. And you can see we kept up the 1.3 amp discharge, and my 4S lithium pack started down here about 15 volts, and it ended up about 15.5 volts. So that's why I wanted to have the battery pack pretty fully discharged, so I had room to put all this energy, and that represents about 300 watt hours of energy that got taken out of the lead acid battery. That's a pretty fair voltage rise there, half a volt. And you can see here in the red is the lead acid voltage. So a couple of things. One is it's a really nice, pretty flat curve, falls off, you know, once you hit 11.2, 11.1 volts, it drops off pretty quickly. The only thing I noticed here that's a little interesting, you can see, unfortunately, the voltage numbers are on this side and all the interesting stuff's over here. But at the top here, we've got like 13.1. That's where the battery started. And within just a few minutes, it dropped down to something like 12.5 volts here. And then it stabilized. It held at 12.5 and then started falling off in a pretty linear fashion here. So that was interesting. What I suspect might be going on is I might have an oxidized connection or a loose connection between the battery terminal bolts and the actual jump start clamps. So what I want to do is I'm going to charge this battery back up And then I'm going to repeat the discharge and also the internal resistance test, except I'm going to pull the back cover off the jump start pack, and I'll hook the battery charger clamps right to the battery posts just to see if there's any difference, see if the internal resistance is different, see if the capacity or at least the voltage curve is any different than this. So I'll have this number, and then I'll have a second set of discharge tests, and I'll just see if there's something there that I need to look at, because normally you would expect the voltage to start around 12.8, which is just under the green line, and it should come down from there, versus dropping down roughly 0.3 of a volt. And if you figure out at the 1.3 amps current and 0.3 of a volt drop, that's approximately 1/4 of an ohm. It's like 230 milliohms would do that kind of voltage drop. If it is resistance, someplace in the system there's like a 1/4 of a ohm resistance. I didn't see that in the internal resistance test. That showed up as like 90 milliohms. Now the thing I wanted to look at is if we take, say, 12 volts and divide that by the 92 milliohms that we measured for internal resistance, that would be your short circuit current. And that's a little bit low, because I think this jump start pack, at least I think according to the data sheet I have, it was rated at something like 650 cranking amps. As I mentioned in an earlier video, when I first purchased this jump start pack, I actually used it just a little bit. I was testing a portable winch. So this was an 8,000 pound 12 volt vehicle recovery winch, and I was using the jump start pack to power that winch just for testing purposes. I built this winch cradle for a customer. He had a winch, and I built him this winch cradle and put on the 350 amp Anderson power pole connector, and I was just making sure that everything worked before I delivered it to the customer. So that was the one and only winch cradle I've ever built. That was back about 15 years ago when this jumper pack was brand new. That was about the only high current testing I've ever done. So what I'm thinking is I'll retest the internal resistance and the capacity after I recharge the battery. I'll do that off of the battery posts, and if they're significantly different, then I might try investigating the battery cables and the jumper clamps just to see if there's anything there. Because if it is a jump start pack and you need to do a jump start and you can only put out 130 amps, that might not do it for a jump start. So I might want to actually figure out what this is. And then I also want to test with my other battery testing meter. It directly measures the internal resistance and the cranking amps. Anyway, I wanted to show you this discharge test. I mean, the capacity comes out per the battery label. Just wanted to get this first test out there and let you see the results. But overall, I think that battery's okay. And if you have any ideas what's going on here or any questions about that, post up in the comment section below. I'll try to put a couple of videos over here on the side you might be interested in. And if you found this video interesting, give it a thumbs up. And as always, thanks for watching.